Welcome back to my now closed video channel, YouTube video channel. This is a bit of a follow-up to the previous video talking about the amplifier and how it sounds. I'm actually in my lounge at the moment, and I'm going to show you a complete project. Now, on this there's good news and there's bad news, like most of my videos. I had planned to show you how it was all put together, and in fact I've spent probably 2 to 3 days filming this very same thing by putting it all together, showing you how it's wired and everything. That would have been the good news, but the bad news is Windows has just done a major update on my PC, and somehow it's managed to, or I have managed to lose all the files. Now, I don't even have the originals, because normally when I film, because of the limited capacity of the card in the camera, the moment I finished a project, I take the raw files and put them into the computer just as they came out of the camera, and then it goes into the video editing software, where I try and make something watchable out of probably several hours of video. Now, as I've lost all the original footage, there's nothing I can do. It would mean literally completely deassembling the project and starting again, which I'm not going to do that. It's just simply something I just can't deal with and having to do with. So I'm going to do, hopefully, the next best thing. Now, here is the project. Now, if you think it looks staggeringly like the L12 Mark II, that's because I'm using the same cabinet. The L12 has now been completely removed from there, and in fact I've sold the ingredients, so I no longer have the L12 amplifier. I debated long and over a long period whether this is something I should do, but I wanted to get this new project into a cabinet rather than just loose on the bench or on a piece of wood or something like that, which is fine for testing, but you want something a little bit better in the lounge, don't you? Right, we're going to go into the workshop now, and I'm going to show you in detail what items I've purchased to make this a complete working amplifier. Here is the nearly finished project. You'll notice here, by the way, there's an earth wire, because I haven't actually put the lid on this yet, and this has got to be attached to the chassis. This is the main earth wire, and that just obviously connects to the metalwork to make sure that if anything should go wrong, the chassis won't become live. Now, I did mention in the first part of the video that this complete project is a compromise, because one of the most expensive ingredients is the metalwork and the cabinet and heat sinking. And I think I've mentioned many times before that I don't make any appreciable money out of YouTube, so I can't afford to go out and buy a new cabinet to put this in. Hence, I've stripped out the L12, so there's a few bits and pieces in here which I wouldn't use out of preference. Now, this particular cabinet is a little small to get the maximum out of these amplifier modules. You can see it's quite busy inside, and everything in there is used, with the exception of some of the inputs here, and as I mentioned before, the volume pot. The first thing I want to talk about is the mains transformer. Now, if you recall the first video where I ran the amplifier modules off the power supplies on my bench, well, these gave 40 volts plus and minus. You need a plus and a minus voltage to run this, and all the figures that I gave you were in fact based on that 40 volts. This actually produces a little less. Now, in real terms, we'll measure this presently, but the transformer itself is a 24 volts, so 24 0 24, and they're two separate windings, and that you'll end up with about 38 volts of DC. We'll measure it in a minute, and just to prove the point. Now, clearly you can see here there's no more space for a bigger transformer. This particular transformer is a 160 VA, which is, I hesitate to say underpowered. Well, yes, it is underpowered, but that will only really reflect if you're going to be driving it to sine waves, as I've done on the previous tests. But in music, even playing it at horrendously high levels, making my ears almost bleed, this transformer is absolutely fine. And if you touch the side of it after it's been running for an hour, there's just the hint that it's a few degrees more than ambient. So what I'm saying in a nutshell is, if you're just going to use this for music conditions, 160 VA, now this is, I need to qualify this is proper 160 VA, not necessarily Chinese 160 watts. I think you'll know what I'm getting at here. This particular transformer came from a company called Farnell, which is now called Element 14 for some strange unearthly reason. But we all call it Farnell, and probably will for the next 100 years. Whilst this transformer was made in China, it's built to European standards. So if it says 160 VA, that is really what it will do all day and all night. Whereas if you get one from China, the chances are it won't. It'll be smaller, lightweight, and even forbid it might be wound with aluminium wire instead of copper. And you'll probably, in all honesty, be able to buy it cheaper from your local company. It's like Farnell, if you spend over, I think it's $60, don't quote me on this, but certainly in New Zealand, if you spend that sort of money, it's post-free. Whereas if you buy it from China, the price will almost double. So not good value for money, and you don't really know what you're going to get. It's the rectifier and smoothing board. As you can see by the slide, this comes from, I think it's pronounced Yima Global or something very similar. This is where I purchased this particular item, but there are many companies on eBay and AliExpress, to name but two, that sell a similar item. And this is one of those things where it may be worth your while looking around, because this particular one included free shipping. Its claim to fame is it uses shocky diodes, which at this kind of voltage actually gives you an advantage, gives you less voltage drop than you would get from conventional diodes. They claim it's 120 amps, again that's peak, but saying that, they've got some heat sinks on the diodes, which is good. The capacitors are reputedly made by Elner, and the price of the product suggests that this is probably true and not fake. It holds the charge for a very, very long time. When you turn the power off, there are a couple of little LEDs on there, and they remain lit for probably about 45 seconds, depending on the load. So a mammoth amount of electrolytics there, and well worthwhile. It's also got some small capacitors here and here, which go across the main electrolytics, which theoretically help with harmonics and stuff like that. So recommended, don't skimp on that. And you can see that the capacitors are rated at 63 volts, and as we're running on about 40, well within the rated working voltage. Now the little module I'm pointing to now is just something I've built myself, and you can do a similar thing or do it completely differently, but you do need to fuse the secondaries. These are literally, that's for the positive side and that's for the negative side, and I've individually fused it. So if one module should fail, it will take out the fuse and you'll see instantly which one it is. So something like that you need to do, whether you have individual fuse holders. I'm sure there's a million ways you could connect that, but don't omit it. You really need to fuse them. I've mounted this module on the front panel, and it is the loudspeaker protection. I like for a number of reasons. The first one is that it runs from the mains, and it has a little module on there. Will work from 85 volts to 265 volts, so you can effectively say anywhere in the world that you live, you'll be able to use this board. And the relays are low voltage 30 amp types. We'll have a quick chat now about the amplifier modules. I've gone into these in great detail in the first video, so if you don't know what I'm talking about, may I suggest you have a quick look at the original part 1 if you like. Now, in an ideal world, these modules would be mounted in the center here, but as you can see, there is no spare space whatsoever. But saying that, the heatsink is over generous, and under normal conditions the heatsink, if you're just playing music or listening to me for example at normal listening level, these heatsinks, you will just be aware that they are slightly warmer than ambient. I suppose it depends on which country you're living in, because ambient may be twice as high as it is in New Zealand, but you know what I mean. In other words, it don't get too hot. When you're playing these at high level, they get warm, and you can feel they're slightly warmer here than they are here. But saying that, in this particular cabinet, as this is all connected, this is all aluminium, even the front panel gets to about the same temperature as the heatsink, and you could actually run both modules on one heatsink of this particular size. You can see there's a lot of mass here and a lot of surface area. But saying that, why would you want to do that? The cooler the modules run, the better long term. And something I need to mention right now, if you don't know, that means you haven't been paying attention. In the first video I showed you the connections, and I corrected afterwards that the input on the modules, I labelled them round the wrong way, so apologies for that. but I'm sure you would have noticed that by now. It won't do any detriment, it just won't work if you connect it the wrong way round. We're going to measure the HT voltage with this particular transformer and rectifier block. We'll turn the power on and we'll just wait a few seconds, listen for the relay. Alright, the relays have clicked in, so all is well. On the power supply, these two here are the ground, or the zero if you like, and on this side we have the negative voltage, and as you can see on the meter it's 37.31, moving about slightly. I think that's mainly my connections. And if we go on this side, we have the positive voltage at 30, well, just the same thing but positive. So a little, 3 volts roughly less than the 40 volts that I'd previously used on the switch mode power supply. So power will be a little down on this particular version. You can clearly see the 2 red LEDs. That's purely for monitoring. That's on the output basically via a limiting resistor. And I did tell you that it holds its voltage for quite a while. Let me show you. I'll turn the power off. So admittedly it's not playing any music, but the amplifiers are still connected, and as you can see they're holding their charge for quite a while, even though it's drawing the quiescent current from the modules and the LEDs and those bleed resistors down there just out of view virtually. I won't bore you by watching those LEDs, but they'll go on for another 15 seconds or so. A few things to tell you now about the complete project. I've just done some sine wave tests, really just to see what the output power is based on this particular transformer and voltage. And these are the numbers that I've got. With 22 volts across load, which is basically just prior to clip, the usual way, into 8 ohms I'm getting 60.5 watts per channel, both channels driven. Into 4 ohms the voltage drops to 20 volts, as you'd expect. That gives you 100 watts into 4 ohms. Now that's quite a drop from the original tests with the 40 plus 40 switch mode power supplies, and the reason is very simple, partly due to the slightly underrated transformer. Clearly you can't get 150 watts twice out of a 160 VA transformer. It just doesn't work. This is designed to be a proper working amplifier, and in music the voltage doesn't drop as much, and the obviously, I hate to use the word peak power, but that's what it is, because it's the power before the voltage drops, and you get a lower power. But in music you'd never know that the power was as low. My speakers, as I've mentioned before, are nearer 4 ohms than they are 8. So I'm getting 100 watts RMS, so music power. There again, using that. Should be a 4-letter word really, shouldn't it? But it is a true meaning. It does reflect more. I mean, people don't listen to sine waves. Apart from me, I think I'm the only person that does. But it's a powerful amplifier. There's no, mostly because of the rectifier and smoothing block, there's a lot of microfarads there, and it holds the voltage beautifully. But of course it can never hold it on a sine wave because it's a continuous draw, whereas music is all over the place and you don't get that voltage drop. The other thing I would say about the amplifier is it's completely silent. There is no hum, no hiss, nothing. And the number of times I've turned it on and expected to, you always get some sort of slight disturbance, either a click or something, but with that protection board, you don't get anything. The DC offset is less than a millivolt, so you're not even going to get that slight that you get when you've got, say, 50 or 60 millivolts. The other comment that a couple of people have made, they've said, does it get hot under quiescent conditions? Well, I've already mentioned to you how hot it will get will depend on the heat sinks. Obviously, if you've got it bolted to a manhole cover, it's not going to get hot, whatever you do to it. But it actually draws more quiescent current than most amplifiers do. That's because it is two amplifiers in parallel. So you've got the quiescent current of both of them running at the same time. But the current doesn't increase when you start applying signal. Say you're running 10 watts. It's not any higher than if just one amplifier is running, because it's sharing the power. But each module does have its own quiescent conditions, which is not high. But when you're adding them both together, it initially seems higher. There is no crossover distortion at all that I can perceive, even when you're putting 50 kilowatts, you should be so lucky, 50 kilohertz through it at about half a watt, and you crank it up and there's just no artifacts or kinks in the waveform at all, which is how it should be. If you want to actually get the maximum power from this particular board, you will have to run it at plus and minus 40 volts from a stabilized supply, i.e. switch mode. Now, generally, I personally have not had too much luck with switch mode power supplies. If I tell you, I have never had an analog power supply blow up or fail. Never. I suppose the only thing that would long-term fail would possibly be the capacitors, but we're talking about 30 or 40 years before that will happen. And I think it's very unlikely many switch mode power supplies will last that long. It could be my fault because I've tended to purchase them from the usual brigade, and like everything, there are switch mode power supplies and there are switch mode power supplies. Some of them are double or treble the price. So whether that brings you reliability, I don't know, because I've never purchased them at that price. But certainly the ones that are $60 or $70, I find they're not reliable. So if you're building an amplifier for long-term use, switch mode does seem to be the way to go, but if you want reliability at the cost of reduced power, then analog is the way to go. When I say analog, I mean a transformer and a rectifier, like we've got here. Now, one thing I have to mention is you must use single point start earthing. Take all your earth leads back to the zero potential on the rectifier board. Now, there is one very important thing I want to tell you about this. If you look at my first video, you'll see initially I have the input connected via a volume pot. And I think from memory it was probably 10K. I could be wrong. Don't do this. This amplifier board, and along with many amplifier boards, don't actually like a pot directly on the input. And when I first started doing this, you'll notice, if you look at the first video, It starts off with the pot connected, and then halfway through the test it vanishes, because initially I was adjusting the input level on that potentiometer, and when the pot is turned on full there is no issues. But when you turn the pot down to say half of its travel, I found the HF started to roll off, and I noticed it first on square waves, because it's easier to control the input from that pot than it was from the test gear, which is a little bit unfine, if that's a proper word. And I thought, oh, square waves on this are atrocious. And when I tested it again later without a pot on the input, it gave the results that you saw in there. But initially, with that pot connected straight across the input, I was 5 dB down at 20k, very un-hi-fi. And you could hear it, because when I took it into the listening room, I was using that to adjust the volume, and I just had a feeling that it lost its HF sparkle, and that's what prompted me to experiment with it. It's to do with impedance shifting and loading of the input. If you're going to build this, don't put a volume pot straight across the input, because it will affect the high frequency response. It needs a buffer preamp or just a buffer stage. It doesn't have to offer any gain. We might go into this in more details in a future video, but don't put a volume pot straight across the input. It messes it up completely. A couple of people have asked me where I got the module itself from, the actual amplifier module. I'll put a link on here so you can contact them if you wish. Now, as far as I can see, there is only that one supplier that supplies this particular board. Do be aware that there are dozens and dozens of different boards that use this particular chip, but this is the only one, to my knowledge, that is based on the name Amplifier. How closely it follows it, I don't know. They are not just two amplifiers in parallel. You can't literally just link them up. One of them is the main driver and the other one is a slave, and it's connected in a different way, but for all intents and purposes they are in parallel, and that's one reason why you get such good low impedance results. I've tested two other boards in the past and got various results, but this board is by far the best. It's completely stable. You can hang capacitors on it and it doesn't ring, it doesn't oscillate, and sonically it's by far the best. So it seems that the chip itself is excellent, but some of the implementations, that's the word I'm looking for, of it do influence the sound, and also the board layout seems to be quite critical. This board is rock stable. Don't be tempted to look at some of the lower cost ones where the, if you like, the pre-driver chip on it like this one does, because I haven't tested them and I don't know what results. I don't think I want any more. I mean, this would be the third one that I've built or use, and it's by far the best, and it's the only one that I would genuinely recommend. So good luck if you're going to build this. I don't think you'll regret it, and sound wise, I hesitate to say I prefer it to the L12. I think I possibly do. But you never heard, you'd never thought that I'd say that, ever. Build it. You won't regret it, I promise you. Thank you for watching. Much appreciated.